this is us. June 2023, so more or less 2 years ago. As you can see, we were in front of a group of business leaders, and we were rather early in the LLM API game, and we were very eager to show them endless possibilities to a room, in 2023 that was rarely acquainted to ChatGPT. And of course, what we did was we showed them stuff like that. Right? Many of you will probably recognize that. Neat little Streamlit apps with neat little prototypes. And as it seems, we were quite convincing, because as it turns out, we found our first customer there. To be perfectly blunt, our first customer actually found us, because he convinced us to bring something to production, which then led to us creating a company to do more of that. And, well, that's when we started producing prototypes. And this is what we want to talk to you today. How we went from prototypes to production, and the ups and downs that we had on our journey there. Just to manage some expectations, this talk is great for you if you are just in the phase of maybe copying some Medium articles and trying your first steps in LLM applications. It is when you are where we found ourselves, in the middle of, we now need to bring this into production and company-wide rollout. And, well, of course, it's also there for you if you're already a GenAI maven who has done that a lot, and we're happy to, compare notes or to learn from you. It is probably not for you if you are a Streamlit superpower user. If you believe that everything can be achieved with Streamlit, then we don't want to argue with you, because we know you can. We've been there, right? We've done it all. The CSS hacks, the monkey patches, the singletons to keep everything on track. We've done it all. We know it's great. We still use it today. But for us, there was more. And that's what we want to talk about. Now, to give you a brief foundation, here's what we actually do at neunzehn, the company that we started. We do AI sprints. That is, we identify generative AI use cases. We build prototypes together with customers and evaluate them. And, if they have value, we then roll them out company-wide. It's somewhat similar to what, some of you probably do in some LLM lab of larger corporations, just for those who either don't want to have their own LLM lab, smaller companies, or would prefer to work with someone on the outside who might, in some cases, be able to do things faster or whatever. Now, so this is where we need to excel, building prototypes out of use cases, right? And what we want to show you today is 3 major walls that we quite heavily ran our heads towards. And the first one is the user experience, and mostly mixing the front end and the back end. To those of you who have maybe never used Streamlit, here's just a quick example. I stole that from their documentation, which is also really awesome. And you take something like that, so really just a couple of lines of code, and you get something like that. Right? If you create a prototype, that's just awesome. Now, you sparkle some additional elements here, right? Some length chain, some llama index, whatever you want, and you get a really awesome, convincing application for your users. And sooner or later, our demos and apps looked like that. You know, you can achieve a lot. And in many cases, the customers loved it, right? Because it could make stuff for them much easier. It basically automated a lot of the boring stuff. You know, we are talking about German Mittelstand, and you have to think about the shop floor downstairs with all the machinery. Everything is kind of automated, otherwise you don't produce in Germany. And then you have the administrative floor, and there many people are really, really doing, you know, rather boring, repetitive stuff, copying and pasting info from one piece of software into another, stuff like that. So they loved it. Now let's start from there. And of course, once you roll something out like that, you know, you have changes. Meet customer expectations. Add some more pages, you know, we've done plenty of that. That's easy. Add a logo, that's easy as well. You know, maybe change some of the user interface. You can do that, as I said, we've done it all. Add more functionality in the middle of somewhere, add layout instruments, and then at the end, you know, can you just change the whole structure? And we could, and we did. And you know, it's really awesome because you just mix and match UI elements with your code, and well, at the end, our code looked somewhat like that. And as I said, we've tried it all, but we always ended up, you know, hurting our heads trying to run through this wall. So, what did we need? Our objectives. We needed a clear separation from front end to back end. And what we've done to do that is we used FastAPI. It's a really great match because it does asynchronous tasks very well, which kind of makes streaming less of a pain than it is. But we also wanted it to be front-end independent, you know, without too much effort. So what we've done there is our default nowadays for chat operations is Open Web UI, and we basically created an API that just behaves somewhat like OpenAI's API, which is kind of the de facto standard. So if it talks to OpenAI, and most front ends available in this realm do, it can talk to our backend. Right? We basically pose as a model to use our functionality. Well, and then of course we needed a lot of flexibility because not everything is chat, and we also needed backward compatibility and sometimes, you know, just user-specific or customer-specific front ends. So we can always add another route to FastAPI with another API and use Streamlit. As I said, we still use that heavily, and adapt to whatever our customer needs us to be. Now, so far regarding the first challenge, you know, the front end, and with that, I'm happy to hand over to Frank to dig a bit deeper into our stack. Thank you.
Thank you, Thomas. All right, so our next challenge, and I think every one of you might be familiar with this. So it works on my machine. As Thomas showed you earlier, this is our starting point. This is how we started. We showed this application, and everyone in the audience was surprised that this is working. And basically, all we did is we showed some Streamlit code. At that time, we used a length chain in Streamlit, and we showed this application running on our laptops. So basically, everything you needed was on laptops, except for the API calls for the large language models. So just simply enough. but as Thomas said, people liked it, and they asked us, okay, great, but how can we use it? So how can we access it if a user in my company wants to test it or wants to use it? And I think the answer to that, at least it was the obvious answer in our case, was, okay, just use containers. I mean, build up in a container, put in everything you need, and then spin it up and make it run for your clients. So what we did is we rented a server at Hetzner. We set up Podman, we created the compose file, we created the systemd files or service files. We created some shell scripts to automate the deployment process, to make this as easy as possible. And in the end, people were able to access our infrastructure, our applications, and we were successful, right? Yeah, unfortunately not, because what we learned at that point in time is that especially the German Mittelstand, they are not so much willing to provide you data which is not running in their systems. So what we needed to figure out is, okay, how can we make sure that our applications will run on-premise in the specific customer infrastructure? And what we also needed to do is we needed to scale up. So we needed to learn about specific infrastructures, especially when they are several years old, like the network setup, the firewall setups, and so on. And we started with creating Linux machines at customer side, and then made sure that our containers are running there. We set up a private repository for the containers. So everything was working great, but then the requirements got even higher. And the highest requirement we had so far is that our customers wanted us to use Azure. And I'm not sure who worked with Azure before, but let me tell you that. It's quite complicated, and it was quite a challenge for us to get to know the specifics, how to set up an environment which was capable of running the container infrastructure we had in place. But we managed somehow, and what we saw is that, I mean, this on-premise hosting is challenging, but there are also techniques like infrastructure as code, like Terraform and Ansible, or the Kubernetes topics, which is something which, at least this is our hope, help us to make this a little bit more easy for us, to make this on-premise hosting more declarative and more reusable. But we are not there yet, but this is our path right now. But I think the good thing about this, it works on my machine, is you can start very small. I mean, set up a container on your machine, and you can easily scale up depending on the requirements you have on-premise at your customers. So the next challenge, challenge number 3, and I think this is the biggest challenge for us, because our value proposition was always, okay, you can use AI with your own data. And as Thomas showed you before, this chat with your PDF was something which really blew people's mind. So what you were able to do is you were able to upload a specific complex document like the European AI Act, and then you ask a specific question and you get an easy to understand answer. And maybe for the first time in history, people were able to understand what's written in those specific regulatory documents. So, I mean, people loved it, and we were successfully prototyping applications like this, but then they started to provide us more documents and more documents and more documents. So for us, it was not so easy. Okay, how to figure out what document do we need to answer this specific question? Luckily for us, there was something which was developed quite early. It's retrieval augmented generation. And the basic idea is just that you have a specific preparation process. Now let's see if this works. Okay. You have a specific preparation process, and there you take your documents, you use a specific embedding model, and then you create so-called semantic vectors for specific text blocks. And whenever a user is asking a question, you again use the same embedding model, create semantic vectors, and then you look for the similar vectors in your vector database, retrieve the specific text blocks, and then send it both to the large language model to answer the question. So it works great. And we also used this quite a lot. But then people were sending us, again, more documents and more documents and more documents. And the worst thing about this is that our companies are manufacturing companies in Germany. And what they do is they provide or they produce a lot of products which are very similar, but there are specifics which are different. So for us, the biggest problem was whenever someone is asking a question and wanted to have a specific answer, like how much power has AMB3X has, then you need to find an answer which is specific for this product, not something which is similar, but the specific answer for this specific product. And that was not so easy to be achieved with the standard RAG approach. So it got worse and worse until it was not good enough. And we needed to figure out, okay, how to deal with this now. And what we did is we now have a more advanced RAG strategy, and it looks a little bit complicated, but I think the most important thing for us, which really leveled up our quality in regards to specific answers, is that we introduced, let me try this again, no, that we introduced this context information database. So what we are doing is, when we are doing the preparation of the documents, we try to get out as many metadata or classification information as we can. For example, what is the specific product which is covered by this document, and then store it in an additional database where we also can add additional information, which then can be used to filter out the specific semantic vectors in the vector database, and so achieve a higher quality and a more precise search for embeddings which are relevant for the queries. For example, if I take a product question like the SMB3X, I know, okay, please only look for the semantic vectors which are for this product. So it's working quite well. But this also led to a little bit more complex architecture. So remember, we started with a simple Python script. This Python script was running on our machines. And now we have an infrastructure which looks like that. So what we do is we have... move it more. Oh, yeah, there we are. Okay, now I'm pointing in that direction. So we have a front-end container, and we talked about this earlier. We have Open Web UI, and we have front-ends like Streamlit and maybe other things. Then we have our back-end container, which is running most of the logic. So we use right now, it's the new kit on the block, and we like it. It's Pydantic AI for the agent framework. We already mentioned FastAPI. We use Llama Index for the RAG operations. And then in addition, we have Postgres for the contextual data, which is also running in a specific container. And we have Qdrant for the embeddings, because Qdrant has a very powerful filter mechanism, which we use in combination with the context data we stored in the Postgres database. What we have in addition is the LiteLLM proxy, which is a simple proxy which takes your large language calls and then move it to whatever model you are using. And the main benefit for us is not that you're taking with the same interface, but that you have also something like budgets you can assign to specific products. So you can generate specific keys for specific projects, and you also have something like a calculation. Okay, this is how much money was used in this project for that model, and you get an understanding, okay, what operations are costly and what operations are not. And then, and that's the last part, the hosted models, I mean, can be hosted on Anthropic, Meta, or OpenAI, but also maybe in your cellar if you like, if you have enough money to spend and use an open source model. So an overview for our architecture. For sure, there are some other aspects, but I think those are the main blocks. What are the next steps for us? I think everyone right now is talking about the model context protocol. For sure, that's also a topic for us, especially thinking about creating a server which is capable of providing us specific functionalities. Then we need to figure out how to better test our applications, because as you saw, this infrastructure is quite complex, and also this whole advanced RAG process is quite complex. If you change something there, something else might fail, and we need to have a better testing mechanism in place to make this much more easy to test. But last but not least, and I think this is the most important one, this area we're working in is so fast moving, you don't know what hits you next. And this is also what we learned, that whatever plan we have is not the plan we follow. We are also a little bit guided by whatever technology breakthrough will be there. So that's it for all. Thanks a lot. And we are happy to answer questions.
Thank you so much for your enlightening talk. We already have a few questions. If you would like to ask a question, go to Slido. You can find the link in the Discord channel of the Helium-3 room. And if you want to push a question, you can like it. Okay. The first question is, why did you decide against storing embeddings also in Postgres with the PG vector extension?
Good question. We started quite early, and there at that time we used Chroma, and then we moved on to Qdrant, because Qdrant has much more powerful filter mechanisms. To be honest, we had a look at Postgres vector, but we are not sure if this really helps us at this point in time.
Right, thanks a lot. Then the next question is, how are your experiences with Gradio? It claims to be production ready.
I mean, we had a look, but to be honest, we didn't have time to look into this in more detail. And what we had so far worked quite well.
All right. Then the next question is, do your customers chat with internal documents? How do you deal with company data being fed to a public LLM?
That's a question we get every time, in every, even in the demos we do with leads that we have. And well, one of the reasons why we do what we do is that you can run it on premise. At the end, when you do a trade-off between what's the cost of having everything, including GPUs on premise, and doing some cloud stuff, the typical path that we see in our customer base is that they have some connection to Microsoft already, right? And there's a lot of data already somewhere in Microsoft services, and then using endpoints in Azure that are quite readily available for the most important models is typically the trade-off. But there are cases, medical data, for example, where you want to have stuff on-premise all the time. At the end, it's a cost-benefit decision that companies then have to take.
All right, thanks a lot. We have a couple more questions, but keep on asking. We have a lot more time. How do you learn about your future clients' problems? How do you find potential clients?
Well, maybe let me connect it with the question that I've been asked on the, or that we have been asked on the aisle. How or why, or how do we make sure that customers love or users love the GenAI application? An answer to that is that we are both from the innovation field, and we have a very user-centric approach. That is, whenever we start a project, obviously we talk to some sort of project team, But very, very early, we insist on bringing in people that actually need to use the application and work with them and understand their problems and create prototypes that ideally from day one, even in testing phase, can already save them some time. Because that's all about in our space, basically, we need quick ROEs, right? We're not talking with large companies that do something just to learn it. Our customers typically want to have some benefit out of it very, very quickly. How do we find them or get to know them? By exposing ourselves, not only here, right, where it's about Python, but at conferences that it is targeted towards our potential customers, to talking with chambers of commerce, stuff like that, and then talking to them, understanding what their problems are. And of course, we are pretty sure that 2 years from now, we will do something somewhat similar, but very different as well. So it's a fast-moving field. I hope that answered most of the question.
All right, thanks a lot. What tool or program are you using for the pointer?
That one? That's a weird Logitech thing, and it's not working.
All right.
Yeah, it's Logitech. It's basically the reason why they produced it, I think, or why I bought it at least, is the chances are that if you're flying, that they take away your laser pointer because you're not allowed to bring it into the cabin is quite high, and that's an alternative.
How do you use Light LLM to track query costs?
If you use a Light LLM, I mean, there are 2 points of Light LLM. You can use it as a library inside your code, but you can also install Light LLM as a proxy. And then there's an easy way to assign for every model you integrate. You can assign how much specific tokens will cost, and then you have a nice overview. Okay, what are the costs for this model or for that project?
All right, thanks a lot. What does your pre-processing and context enrichment look like for embeddings?
For embeddings, let me go back. It's quite straightforward. I mean, I think the most magic happens here with the metadata and classification part. Right now, we are experimenting using LLMs for that, also for analyzing what kind of document is it like. Is it a brochure? Is it a technical document? And then we use the embedding models, and I think most of the time we just use text embedding small, the newest model from OpenAI, and use it as it is, and then enrich it with the metadata, which we find relevant.
Cool. Thanks a lot. Do you ever get hired for a use case and then realize this can be done easily without AI? If so, how do you handle this?
Well, there's a common pattern. We get in a room, and then typically, of course, there's some decider in the room, etc. And in quite a few cases, the decider, kind of also falls in love with potential AI applications and the technology. And one of our main tasks, and in this early phases, is again then to really break it down to what helps, right? So what really can generate benefits for users, so to get the perspective of the employees in the company. And yes, we had cases where it was not useful to use any LLMs, or it was an unnecessary overhead, and then we either hand it over to someone else, or we do it without LLMs.
And maybe to just add something, this chat interface and this RAG, this Retrieval Augmented Generation, I think the biggest benefit customers have is to find their own documents. So it's not so much about AI, it's just, okay, we had a document about this, okay, just find me this document. So it's not so complicated from an AI perspective, it's more search and find information, but it's still very valuable.
All right, thanks a lot. Maybe one more question. Can you say a bit more about the experience with FastAPI?
It works.
That's perfectly.
Feel free, to approach us later to, ask more about our experience more specifically, but we're quite happy with it.
Cool. Thanks a lot for answering all those questions. The Fragenhagel, we say in German, the question, hail of questions. One more thing, before you leave the room, please take all of your stuff, especially the glasses and the cups with you. And with that, let's thank our speakers one more time.
Thank you.